Recording is on.
As you might expect.
Do you see the main slide?
Yes.
Okay. Today I would like to discuss, first present, briefly describe the proposal of the new invoicing standard, explain why we need the new invoicing standard. The main need actually, of course, comes from the RGB technology we are developing, but actually we understood there is a lot of unsatisfied demand on the market outside of RGB scope. So we try to develop all the ideas we've been discussing throughout the whole year, put them all together. You may check our previous calls, like the calls that we had in September, when we were discussing a lot of concepts around how invoicing can be improved and implemented on top of RGB, and also in spring. And this all came together. So after student research on existing standards, we have, I would like to propose this overall concept of how a next generation of invoicing can be organized, and see what do you think about that, and let's have a discussion over the next weeks of what do you think on the standard, how it can be improved, what can be changed, and so on. There is not a lot of slides, just 13 slides, unlike on the previous calls when we had a presentation of 100 slides. So that would be really quick, and I would like to reserve as much time as possible for the discussion. So what we have today in terms of payments in the Bitcoin ecosystem before this proposal. Of course, we have Bitcoin addresses, which is quite the most well-known format of providing information when you need to receive some payment in Bitcoins. So far, we have two standards. The initial one as a text or string starting with a number like 1 or 3 for script-based outputs, and the new version for SegWit outputs, which is called Bag32. Fortunately, Bag32 had some problems with the used version of Bag32 have some problems with the length extension of the address, opening a way for very low probable, but still a way for attacks. So it will be updated with the Taproot proposal, and it's being discussed today how it could be updated. So we basically have 2.5 address-based standards. The problem with these standards is that they promote a bad practice of repeated use of public keys, which opens privacy leak such that other people would be able to see how much money do you owe in total on that public key. The second standard in the area of payment that we have is Bitcoin URLs. It is defined in BAP 72, and it is basically a use of the same addresses plus Bitcoin colon prefix, making it looking like a URL string, and the question mark after which you can specify amount or some additional fields. So basically, it's just an extension of the same address concept, having all the drawbacks of the address format. And the other problem with that, comparing to back address, that back address is designed so you can double click with the mouse and it will select the whole string, and you will be able to copy it really simply. Or on the mobile phone, you tap and the whole address is selected. However, with the URL format, you select without the Bitcoin prefix and without amount, which is not very useful. And then, especially on mobile phone, it's really inconvenient to work with them. And the third standard being used today is Lightning Invoices, defined by Bolt 11. And basically, it's the only way to pay in Lightning today. So I wouldn't be saying about drawbacks, because basically we have a lot of other options. However, the big review of Lightning invoicing drawbacks by Rusty Russell, who have created a new proposal. So in the second part of the slide, on the right side, you see the stuff that is being developed today. So on the left side, we have what is used today. On the second part, what is being developed today. And today, the second bullet point is actually the Rusty Russell proposal about invoicing protocol, bold 14. I invite everybody to look into it and read it. He has a lot of thoughts about how the proper invoicing should be made. And many of those concepts and thoughts actually came into the proposal that I will be discussing today. Why we need this universal proposal if we have a Rusty Russell's one? Well, because Rusty designed it only for Lightning Network, while we have to support a lot of RGB specific stuff, including on-chain payments. So basically we can't apply it as it is. So we had to modify and develop his concept into something larger. The second thing that is being developed today, already started used, is LN-URL. It's basically like Bitcoin URL. It's a way of presenting Lightning invoice as a form of QR code and with the ability to dynamically and interactively request the Lightning invoice using the URL encoded in the QR code. And finally, the thing that is being already developed but not yet being used is the invoicing that we've done for RGB. It is based on Alekos Fellini proposal in the spring. And basically, it's a BAP 72 with some additional fields after the question mark, and modification of the address, because in RGB, instead of the address, we are using UTXO, and this UTXO is hidden with a hash function, so we use a different backstring as a main part of the address. However, it has all the drawbacks of the BIP 72, and it doesn't support Lightning at all, and it doesn't allow you to do a single click or tap copying, and the most worst scenario, it doesn't cover even all of the on-chain payment scenarios that is out there. So you can pay only if a person you are paying to has a UTXO, which he can dedicate to RGB, which is not always the case. Also, you can't do repeated payments, and you can't do, basically the UTXO-based payments in RGB, they have a very short living time. And because you don't know the UTXO you're paying to, the transaction ID you're paying to, you don't know is it spent or not. And if it is spent, this actual assets got lost. So basically, I would discourage from using this standard any further, and that's why we actually need a replacement. To summarize, what are the problems that we have with invoices today is, first of all these invoices that we just discussed on the previous slides, they're channel specific. So they are really specific for a particular form of payment, Lightning based or other form of payment. They don't support different asset types. So the only form of payment that can happen is Bitcoin-based payment. While with the development of RGB protocol, or even with existing protocols like confidential assets, we will certainly need support for multi-assets. And the Lightning Network itself is a multi-asset protocol. All of these methods are leaking confidential information in that or other way. Even the Lightning invoicing, again, I wouldn't spend time right now. You can listen to the Rusty Russell presentation on the last year, the Lightning conference. But basically, for instance, in order to demonstrate the signature of invoice, you need to expose all the invoice fields. They are not extensible at all. Both in terms of protocol upgrades, the invoicing protocol upgrades, or in terms of vendor-specific custom data that some vendors would like to add to the invoicing. So each time you need to change something in the protocol, you have to invent new standards. Each time you need to do something specific for a software, you basically, again, need to do something custom outside of the standard. So clearly, it's not the way to go. The encoding of the invoice protocols is very inflexible. Like they always have a strict form of encoding, only one way of doing that, which prevents you from using that in different mediums and forms. For instance, the normal Bitcoin addresses can be transferred over the network only as a text string. You can't binary encode them. The Lightning invoice as a back32 string can't be transferred over the Lightning Network messages in other form than the text, which is very unnative and inefficient. Usage of these strings in QR codes, again, you don't have a standard way how to denote software, how to treat this information coming from the QR code. So basically, the fact that invoice data structure and encoding of the invoice data are part of the same standards, and they stick always together one-to-one, makes the protocol inflexible. They are very limited in their functionality. Most of the standards, except Lightning invoices, they basically do not allow you to specify any data at all, like expiry or anything like that. Lightning invoices, they do have expiry date and some additional information, but again, they are not very much extensible. And all invoice standards, they have very low protection, maybe with except of Lightning invoices. So this basically, the invoice is not signed or not related to merchant, even if the merchant would like to establish this connection between the merchant and invoice, so it's not possible to do. So that's why we need to decide something more flexible and probably more universal. And I will explain the overall concept of the universal invoice, which is at the same time very simple and very flexible. So the universal invoice proposal proposes to have three components of the invoice. The first one is a list of beneficiaries. What is beneficiary? Maybe the term is wrong and we need to use the other word like address or payment destination. So basically it's an identification
or
of who
sorry,
are
Maxim,
you paying
could be outputs directly, an output list, or it's too much restrictive?
Well, it's not always outputs. It could be a Lightning node address, for instance. So
Right.
Output. Yeah, it's basically whom are you paying to, but not in terms of identity, but in terms of like account address, something like you have accounts in the banking world.
Maybe an endpoint. Well, anyway, we can think about the terminology.
Yeah,
here.
yeah.
Clear.
I think the terminology should be improved. But the idea here is that instead of single destination of the payment, which is the most of all existing protocols, they accept that there are one-to-one correspondence between invoice and receiver. Here we allow to have a list of beneficiaries. And this list, well, first of all, you may say that you can use different beneficiary organizations. For instance, if you're doing a charity, you can pack them all together. But the main use case is that each beneficiary is a payment channel specific. And in this way, you can say that this invoice can be paid with a Lightning Network payment, or if you can't pay with the Lightning, you can pay on-chain transaction in Bitcoins, or if you can't pay on-chain transaction in Bitcoins, you can pay it in USD tethers with RGB. So basically, you can construct a query in the order of your preference as a merchant of the payment methods that the other party can use in order to fill in the invoice. The second part of the invoice, yeah.
I have one question. So, like the multiple beneficiaries are supposed to be like multiple, let's say, endpoint of the same entity, not multiple entities creating a single invoice to pay multiple people at the same time.
Well, there is no technical limitations on that. So basically, it can be both. But I think the main use case would be it's just doesn't make a lot of sense to have multiple beneficiaries.
Okay.
Yeah, unless you can somehow compose an invoice with a non-interactive, with an interactive but non-centralized process, then it's always one beneficiary that will compose with different endpoints. Yeah, that may represent other beneficiaries.
Or you may have some, I don't know, game scenarios like pay any of this, and people are voting by choosing whom they are going to pay. I don't know. There might be some use.
My question was more like if the purpose is to have like multiple option or pay this amount to this and another amount to that, like to divide the payment to multiple like.
No. The invoice has a set amount. So beneficiary, I will explain later. Invoice basically says how much you need to pay, but list of beneficiaries describes where the payment should go to, and you can select only one of those options.
Okay, understood.
So sorry. So this invoice will not So if I want you to pay 2-3 different addresses, I cannot ask you to separate the payment, one here, and one here. Correct?
Well, I haven't thought about that. I would say that it could be done with the current proposal, but we need to add some extension to it. But because you will see it's very extensible, maybe it's a good point to add. So let's.
That may be on the top of my tongue. Could be interesting for stuff like pay join maybe, and could be interesting for split payments. Like I have an agreement that I will retrocede a fee for my introduction fee or something. So if it's not disruptive for the rest of the architecture, it may be interesting to open this flexibility to. If it is too much disruptive, then no.
Well, it's not disruptive. You will see that the thing is organized in a way that it should be extensible and it should contain very simple ways of extending, even without the modification of the standard. And the whole idea that I assume that such invoices they will open a lot of other use cases we are not even thinking of. But I think this use case can be the case that we will cover as a list of cases because it looks interesting. So let's. I have a last slide where I say what questions we may discuss, and on that slide I will add this point to the discussion list. So there is the first section of invoices, basically a list of beneficiaries. The second section of invoice is very simple. It's a network magic byte specifying over which blockchain we operate. So not an asset, but blockchain, meaning that in which blockchain this transaction is valid. And this will be specific for Bitcoin main chain, Bitcoin testnet, Bitcoin signet. It might be some custom reg test or liquid, of course, or maybe future side chains that may appear. Of course, somebody will use that for Litecoin or something like that, but it's not that the reason why we're designing it. So, but we're committing to the used network. The same way we do that in Lightning, basically. And there is, but this ID is short. We are not using the Genesis hash as we do with this asset ID. First of all, just to save the space, because the network magic ID is 4 bytes and the hash is 32 bytes, and we need to maintain the size of invoice as small as possible. And the second, because asset ID is basically could be an ID of client validated data like RGB. Well, here the context is that we are talking only about the network as a blockchain. Blockchain run by a peer-to-peer node. So we are using P2P network product magic ID. And the third part, the main part of the invoice, is the list of optional fields structured as TLVs. What is TLVs? In Lightning message standard, bolt 1, we have concept of type length extensions. Type length value extensions. So basically it's an encoding standard where you can add arbitrary data to a message. And if you don't add any data, you basically do not add any bytes. But when you add data, you can add data of different forms and formats without modifying the spec. How it works? Well, first of all, it's a list of fields, and if some of the fields is absent, you don't occupy any space, even you don't put a zeros there. Each field, if present, it has a type ID, and this type ID is maybe of even or odd type. Numerically, it's a number. So if you have an even number, it means that the payer, the person who pays the invoice, he must know what is the type of this, what are the data behind that type. He must be able to interpret those data. And if he is unable to interpret those data, he do not know about that type yet, he must fail the payment. And there are odd numbers, odd types, and for them, the payer, if he do not know them, he may ignore them and just pay and proceed with the payment of the invoice. What it gives ability to add new types without the breaking compatibility. First of all, you have also two ranges for type IDs. The one range in the low numbers, it's a standard type, and these standard types will be defined by this standard we are talking about, but they also will divide into even and odd. And when the standard will evolve, we will be able to add new fields without breaking compatibility in it too, by using odd numbers. Or if we need an analogy of hard fork, we will use even number and add a new field, and then these invoices wouldn't be able to be paid by the previous version of software. And for vendor-specific extensions, we have the second range in the top diapason of the 32 bits and 64 bits. And vendors may use the same mechanism, and they can easily add whatever information they need, not being afraid that some software wouldn't support it. Because if they will use odd number, the wallets will be able to parse the information anyway and pay the invoice. Or if they need to restrict the number of software that can proceed the invoice, they will use the even number. So it's not the invention here. We just copycat. It's a strict copycat of the Lightning Network format. So we're just stealing the good concept from out there, and I'm explaining how it works there. And I think that it's the best way how it can be structured in the invoice. And again, even this is not my idea. This is the idea of Rusty Russell, and that's the way he uses the TLV data in the new Lightning Network invoicing.
Sorry, Maxim. This is in Lightning Network. This is used only in the payloads, right, and not in the invoice. So we are using it in the invoice, which is actually not used in the current Vault invoice specification. Is that correct?
No. TLVs are not used by current Lightning invoices. It's just a new proposal, unfinished. No, he doesn't differentiate payload there, as far as I know.
Okay.
It's basically the same. Basically, we're stealing the Rusty Russell proposal with the modification that we allow multiple beneficiaries, including non-Lightning Network ones, and that we make all fields optional, because all required fields specific to Lightning Network will be part of the beneficiary.
Okay, sorry, I was probably confused with the fact that inside the Lightning payloads there was an option of even and odd bytes for required and not required fields, but that's probably not strictly speaking TLV.
No, they don't have that. It's a part of new proposal, but not Bolt 11. Maybe I'm getting something wrong, but as far as I remember, Bolt 11, they don't have byte numbers there. They have the text with a single letter denoted by the single letter. So they don't have a good extensibility. And it's only the Bolt 14, which is not a standard yet, which addresses this issue. But anyway, so that's the concept. The idea of Rusty Russell reworked for more generic payments outside even of the Lightning Network scope. So let's start with the beneficiaries. There will be 5 types of beneficiary: addresses or payment points or endpoints, whatever we will name them. The first type is existing Bitcoin addresses. We will support all Bitcoin addresses, including the future one. It's just that if the software will meet the address that it can't interpret, it will ignore it and proceed to the next beneficiary. And that's all. The second type of beneficiary is RGB blended UXXOs, which are using as a part of current RGB invoices, but it's basically back32 string starting with UTXO 1 and then hash of the transaction out point plus some random data generated by the merchant. And this random data, called salt or payment secret, they are kept by the merchant and or blending factor, and they are required by the RGB node when the merchant accepts the payment. But they basically guarantee the privacy that when you use this invoice format, the payer wouldn't know anything about UTXOs you are owning, which is much more efficient than with the Bitcoin addresses. The next type is descriptors with a custom mini-script. And with that descriptors, you can allow multiple payments. Basically, people will derive the keys for you and generate the Bitcoin address to pay to. And these mini-script descriptors, they can be used as with Bitcoin and with RGB assets. So they work with both of these types. The fourth type is a partially signed Bitcoin transaction based. So you include a partially signed Bitcoin transaction. And this allows you aggregation of multiple payments, or use in such scenarios like when you need to spend some multi-signature address and you use invoice not to pay to somebody, but to organize a payment from your side. And you create, not a merchant creates invoice, but you actually create invoice and share it across people who pay the invoice, and inside it has this partially signed Bitcoin transaction. And the last part, and it's very good also for hardware security devices, because they are adopting PSBT standards, and it will be much easier to sign such transactions with them. And the last five beneficiary type is the Lightning invoices, which specifies receiving node ID plus its address, supporting Tor addresses as well, and some additional data I will be covering a bit later. So the comparison of all this beneficiary type are done in this table. You see that they are very different in trade-offs, and that's why in the discussion in September, we decided that we need all of them. Depending on the scenario that you use, you will choose one or other. And because you can provide a list of these payment methods, as a list of beneficiary addresses in the invoice, the payer will be also able to choose which transaction construction method he can use. I wouldn't be going through these details. We will publish the presentation and you can dig into it. But basically, maybe I need to add a line for support of RGB assets. But basically, you see that they are different in confidentiality properties. They are different in size footprint. They are different in whether they can be used with repeated payments or not, and so on and so forth. So what about Lightning address, which we use here? So we're saying that this fifth beneficiary is Lightning, and we call it Lightning address. Again, the term probably we need to replace. But basically, Lightning address is a part of the Bolt 11, current Bolt 11, which is Lightning node specific and which is required to be present. And this Lightning node address is constructed of node ID, of course, node IP address, node features, hash lock for the Lightning payment, CTLV expiry number, again, specific to Lightning network, and path hints. Again, you can have 0 of them, but you can also provide with some path hints. So basically, it's this extraction of Bolt 11 standard for the part that is specific to particular node and particular payment. Other fields from Bolt 11, they are also included into invoice, but not as a part of this Lightning address, but as a part of this TLV extension data, because you can provide, for instance, several Lightning nodes in the same invoice, and they will share the same amount of payment and other parts of the information, but each of them will have a specific hash log, will have a specific node ID, CLTV expiry, and path hints. So that's why that separation.
Sorry, Maxim, can I ask you two
yeah.
questions? The first one is,
Sure.
this Vault 11 information inside the so-called Lightning address should include also the relevant information to open a channel with the node, right? Because if you have the node ID, because I'm thinking about the typical a typical setup that the user may want to try is pay me with a Lightning transaction with this route. If you cannot, because there is no liquidity on a route, or the route doesn't respond, then you can try to go on chain, but not just to pay me, but to open a channel with me. And only if you cannot open a channel with me for some reason, then you just pay me on this address. So this Vault 11, in theory, gives the other node all the information needed to open a channel with the node, because there is a node ID and you don't need anything else, right?
Yeah, but basically you have a node ID here as a part of beneficiary.
Yeah, clearly. And the second
so
question,
also,
okay,
yeah. And I have a separate section on invoices to open a channel.
Okay,
discussion.
thank you. Okay, perfect. And the other question was, if I remember correctly, in Vault 11 there is already an optional field about a fallback on-chain address. So there may be some redundancy, because
Yes.
we may have an on-chain beneficiary, but also a Lightning beneficiary. But the Lightning beneficiary could include an on-chain address for fallback, if I'm not mistaken. So maybe we have
Correct.
to reorganize stuff in order to be not redundant.
But here we are not redundant, because we are not including this part in the Lightning address. And we have a conversion from Vault 11 to the standard, which always succeeds. So any Vault 11 invoice can be converted into this invoice. And if this invoice provides a fallback address, basically it results of invoice of this type with the two beneficiaries. The first one is the Lightning node, and the second is on-chain Bitcoin address.
Thank you. Perfect.
But of course, not all of this type of invoices can be converted back into Vault 11, because, for instance, you can't provide a mini-script descriptor. But if you have this new type of invoice with a Lightning and Bitcoin address destination only, you will be always able to convert it into Bitcoin Vault 11 invoice. So they are very interchangeable. Okay. So, sorry, I have a broken animation here, a lot of text, and I need just to add it here. Once again, we're back. So do you see the screen?
Yes.
Okay, now, what optional fields we include as a part of the invoice from the very beginning? Again, I'm emphasize on optional. So each of these fields can be skipped, and there is part of standard saying what should be done if the field is skipped. However, we define the standard types, which will be even byte, meaning that the payer must understand them from the first version, but because they are already part of the standard, it wouldn't be a problem. And these fields are shared across all the possible payment methods we call beneficiaries. So the first one is the most, it's quite easy to understand. It's an asset ID. And it's either present, and then it's 256-bit hash of the asset, or if it is absent, meaning that the payment should happen in the Bitcoin or the native blockchain coin. So in case if you will use a network, the other network ID, like Liquid, it will be Liquid Bitcoin. If you use testnet Bitcoin, it will be testnet Bitcoin, and so forth. So when it is present, it has the same meaning as the chain code in Lightning Network and as an asset ID with RGB and LNP, which is basically either a hash of genesis or a hash of asset genesis state transition. So basically, we use the same data structure. I'm not sure whether it is compatible with confidential assets, but I have a feeling that it should be compatible with confidential assets because they also have 256 hash ID. Yeah, here we denote in which asset we would like to receive the payment. And if you would like to receive a payment in multiple assets, well, you need to create multiple invoices in this case. We do not support that, and I don't think that we need to go into that kind of complexity. But again, let's discuss that. The second thing is the price. And why we're putting a price, not an amount of payment, I will explain later. But it's really important difference. This is a price of per each item. And basically, if you are paying for one item, it's basically the same as an amount. Its idea, again, it's coming from the Rusty Russell idea. And the payment that you create with invoice can be actually a multiple, the amount you're paying can be a multiple of this price. And this multiple will actually signify how much of the service or goods you're buying. So I will go into this quantity thing to explain why we need price and quantity. The idea is that we may have a micro or nano payment scenarios, like when we are paying per second of the video, or per kilometer of the autobahn, or per message that we send through some chat. And of course, in case even of goods, if you're buying a coffee or pizza, you would like to buy a number of cups of coffee or several pizzas. So instead of saying the whole amount and having interactive protocol where we communicate to each other the amount you would like to buy and receive price, and even in Rusty proposal, we still have this interactive protocol. With these two fields, price and quantity, we are able to move from interactive protocol into non-interactive protocol, but still be able to buy multiple items. So basically, merchant says us, what is the price per item? And by paying multiply of that price, we inform merchant that we would like a number of that items. And the quantity field allows merchant to limit the maximum number of the items that can be purchased, or a minimum, which could be a case, for instance, when you're buying a seconds of video, the merchant can say that you must buy at least 10 seconds of video with this price per item. And there is a special meaning for zero value. So if the price is omitted from the TLB structure, it means that either you can pay whatever you like. So it could be useful for charity scenarios. Of course, if you don't like to pay, you're not just not paying. Or it signifies the invitation to open a channel. So if it is a Lightning Network and you have a zero amount, you can basically send a channel opening request with the amount you would like to put into the channel with this peer. And when the quantity is skipped, it is basically meaning that the quantity is restricted to 1 and price is in fact an amount.
Very nice.
Oh, cool. The next thing is a fiat requirement. It's another thing that comes from the Rusty Russell, but I reworked it a bit. And how it works. The core concept here is that the merchant should have the ability to inform the buyer about the terms. And because of the price volatility, when you pay in price volatile assets or in Bitcoin, before the hyper Bitcoinization, how it works today. Basically, merchant tell you that you have 13 minutes or 13 seconds to pay the invoice. However, he can't put that as a part of the invoice itself because there is no field. There is expiry field in the Lightning invoice, but not in the rest of scenarios. And it doesn't protect merchant from the price volatility because the price volatility is in percents to original price, not in the seconds. measured in seconds, but he can't communicate that information. And he takes the risks, and by that he increases the price. Here, with this information, the merchant, it's an information that doesn't provide from the payment. So it informs you and gives a wallet ability to display in the user interface that if you're paying this invoice, you need to check that the price of the asset paying in comparing to some currency that is selected by merchant haven't changed dramatically. And if it is changed, then some special conditions apply, which usually are on the merchant website or somewhere else, or you have to contact merchant, or you have to discard the invoice and replace the other. It's completely up to the user. But it's kind of information from the merchant under which conditions this invoice is valid. If the conditions are changed outside of these bounds, it doesn't invalidate the invoice. It invalidates the terms of the invoice. So it's up to you to take the risk of payment and then have a second invoice or settlement. Like today, again, if you are paying too late, somebody will return your funds. Somebody will say you need to pay more. And here the same, it's up to the merchant and consumer. It's just an information channel to set these conditions upfront in a standard way. And with the FIAT requirement, we have ability to specify the code of the currency we are using. We are saying that the amount in terms of that private in that currency, which signifies the upper limit for the price, meaning that if the price goes beyond, lower bound. If the price goes below, the merchant basically will receive less than he needs to receive. And URL of the price provider selected by the merchant, which you can query to check if the price according to merchant vision is correct or not. Of course, you cannot agree with this price, and in this case, you are just not paying the invoice. But it gives enough information for you to set all the conditions here.
Sorry, Maxim. One clarification and one small suggestion. The clarification request is, I'm not so sure that in the scenario that you pointed out, the risk of volatility is on the shoulders of the merchant. Because if I show you an invoice which includes, for example, an on-chain payment that doesn't expire, but if I tell you in the invoice somehow that in the protocol that it expires after 30 minutes, and or the price is only guaranteed for 30 minutes, and you as a customer pay me less, basically at this point the risk is on the customer that paid, and I as a merchant can just avoid to send the good or service. So the risk is still on the customer, not really on the merchant in this case. I don't know if I misunderstood something. It doesn't change anything about the solution, just to be sure that I understood correctly.
Yeah, it actually, well, there is initial risk on the merchant, but the merchant has ability to transfer this risk on the customer.
Not okay, not shipping basically the service or
yes.
Okay.
Yes.
And the most suggestion would be just terminological, to avoid the use fiat explicitly, because maybe in an intermediate phase between pre-hyperbitcoinization and post-hyperbitcoinization, the merchant wants to use gold or whatever. So in a way, it could. I'm not sure about. I mean, I would avoid fiat. I'm not sure of the alternative, but maybe talking about assets ID may make some sense here as well. I mean, maybe it's just confusing with RGB stuff, but in theory, the merchant could choose another asset which is priced against Bitcoin as the alternative price reference, and the fact that it's fiat or gold or oil may be completely arbitrary. Even I mean, this could make sense even after fiat collapse in theory.
In theory, yes, but the problem here with the asset ID is that gold doesn't have 256 hash-based asset ID or US dollar.
Right.
So we either need to stick to the ISO standard, which lives outside of the crypto world, but includes gold. So I don't know, it's probably the currency, because the standard defines currency. So the currency is probably the proper term for even
Maybe
for vault
yeah,
transaction.
currency better than fiat. Absolutely.
Yeah, so it will be a currency, and it will be basically an up to 4-letter ticker. So you can even avoid using ISO standard, but you will provide 4-letter ticker uniquely understood by this URL price provider. Yeah, agree on the currency. And that fiat is a bad term. Again, we have this problem here with the animation, so I will show the end slide. And the last 5 fields, they are much simpler. The first one is the purpose. It's basically a string describing the invoice. It's equivalent of the field inside the Lightning Network invoice, and we use the same limit in characters. I think it's too large, but they have it, so we need to stick it in order to be able to compatible and convertible with Vault 11. If you do not stick into 639 characters, you use details field. And again, it absolutely follows the Vault 11 standard. In this case, details provides you with a commitment hash to the actual data of the payment details. However, while Vault have only hash and it's commitment hash of the details, and it says that the exact way of transferring that details should be defined by a protocol outside of Vault 11, which renders literally this thing is unusable. Here we add a second field where you provide a URL with which you can access the details and verify them against the commitment. And we define the protocol by which we should exchange the data. So the protocol is defined by URL schema, this part of the URL before the double dot, before the colon. And if you use an HTTP or HTTPS schema, the response of the server should be just a plain text, which you can hash and compare against the hash. This plain text can be also signed with GPG or PGP signature for verification of authenticity using the key from the signature field, if it is present. So that's the way we basically clarify the Vault 11 missed part here. The last string we have in fields is the merchant. It's the way of merchant identifying itself. So when you're paying request, okay, you see address, you see Lightning node, whatever, but there is nothing in human readable form telling you whom are you paying to. And if you will forget what this invoice is coming from, you wouldn't see that in the interface. So we are providing the ability for the merchant to provide human readable short identification of itself, which is strangely absent from the Vault and everywhere. The next field is expiration date. And it's very simple. It's a timestamp after which the invoice is not valid. So we have 2 ways of invalidating invoice, by time or by price, with this currency conditions we discussed on the previous slide. And the final field is signature. And with the signature, there are few gotchas. The first one, we are using Schnorr type of signature already, and we will use X-only public keys, which is also a part of the Taproot set of standards, which 1 byte less. And the second, we're signing not the whole invoice, but the Merkle tree of the invoice fields, which provides you ability, if you need to prove somebody that you have published this invoice, and but you don't want to reveal all the information about all beneficiaries, or basically all your address and Lightning nodes, you can use Merkle tree path and the signature and use that as a proof. Again, idea coming from Rusty Russell, and he basically developed a standard how this Merkle tree must be formed and Merkleized, so we literally will just use that. That's all about the optional fields. To summarize, we are coming to the end. We have only 2 slides left. The key properties of this invoicing standard, that This is non-interactive standard. So unlike new bolt forwarding proposal, when you have an offer and then you connect to the node and you receive an invoice, first of all, it wouldn't work outside of the Lightning world, or will require some new networking protocol to be designed. I don't want to use just raw HTTP and that kind of internet one thing. We will need something more encrypted and advanced, but again, it makes things really complex. Here, we are having all the information from Rusty Russell offer and invoice of interactive protocol put into non-interactive form. And you have multiple payment options and payment scenarios. It can be constructed, as I said, from Bolt 11 and can be transformed into Bolt 11 if it was constructed from Bolt 11 or contains only Lightning node information for the payment beneficiaries, or at least one Lightning node, because the rest will be skipped. The signatures that I described, and the very interesting part is about QR code representation. The problem with the Lightning invoices, they are frequently too large to fit into the QR code. And how we can deal with that? Well, as a part of standard, we will say that if you need to present with a QR code, you can reduce the size of invoice until it fits by taking the next steps. First of all, you skip all odd TLV fields, which are not required and optional. You then, if it's still large, you leave only a single payment beneficiary, the first one. Again, you're getting rid of a lot of information. If it's still large, you remove path hints from the Lightning beneficiaries, if it's Lightning beneficiary. If it's still large, you skip the signature. And with that, you will basically end up with a Bitcoin address plus amount, or mini script plus amount, and plus asset ID, which will allow to fit into QR code anyway. So basically, there could be multiple QR code representation of the same invoice of different size. And encoding, the most important part. Well, not most important part, but the last important part. Here, we allow, basically, there are different ways how invoice is encoded depending on the communication channel. The invoice itself is a binary data structure. Because it's the way TLV is defined, it is a binary data structure. When an invoice is transferred through the Lightning Network, because you may transfer the invoice as a part of TLV extension of the Lightning Network message itself, or you can create a custom Lightning Network message type to support some interactive payment protocol of the Lightning Network. It is encoded according to the Lightning Network message rules, and basically it is exactly the same rules we are using in the invoice data structure. So basically you can think about this invoice as a Lightning Network message. When you use it with RGB, we encode it with a strict encoding and the standard used throughout the system. For human beings, which is a rare use case, we will encode this as a back32 string, and it's up to discussion which back prefix we will use. I propose the shortest one, which is I. Why the shortest one? Because it affects the QR code size. So just invoice, because anyway, there will be no other forms of money than Bitcoin, and there will be no other forms of invoice than this invoice. So just I. As a QR thing, it is encoded using uppercase back32 representation, but with a URL schema prefix. Why we need URL schema prefix here before the back string? Because the way the software interprets QR codes is when you scan it, it tries to recognize. And if it sees that it has a URL format, it says, okay, so we have this URL prefix, and each operating system today, they have a dictionary of URL prefixes mapped to the software, so they can launch an application and provide the application with the rest of the URL, which is backstring. If we wouldn't use a URL prefix, basically you wouldn't be able to scan the QR code with a system scanner of mobile phone. But you will need to launch a specific application like Bitcoin wallet and scan with that, which limits the use case. So the best way is we just don't encode the backstring, but we add a URL prefix, which is again enhancement comparing to what is done with the QR codes of multiple bolt 11s. That's all. So the roadmap for this stuff is: first, draft a text of standard out of this presentation. There are many nuances that have to be reflected. And also we need to take Rusty Russell Bolt 14 proposal and take the parts which he standardized there, like localization of the signatures and the rest. Maybe invite him into authors or review the standard if he will be interested. Then next, prepare draft implementation in the LNPBP core library. Its very draft implementation is already there. I will be giving a URL in a moment. Then have a community discussion in parallel, setting up all terminology and all aspects, and maybe you will propose different fields or other fields. Then release a language specific libraries so they can be used from different software. Still, these libraries have to be based on LNPBP core Rust code, because there are a lot of RGB specific verification stuff which will be really inefficient if you will implement that again on the native language. So we will use it the same way as I was describing at the beginning of the call with lib-RGB, providing a C library with native language wrappers based on the reference implementation. The plan is to have it implemented in RGB node and LNP node starting from the next version, which will be released in months or so, including to the software that we are doing in my company. I was already presenting Bitcoin Pro, and there I would like to have a very advanced invoice editing where you can add multiple fields, you can create custom fields, vendor-specific fields, multiple beneficiaries, like do all the magic that you can do with that, and have it as a part of my Citadel wallet, which will be one of the first wallets supporting RGB and these invoices. Hopefully we'll be presenting next week, but of course Invoices will be there probably later. And look for other developers and industry to adopt these standards. These are the links to places where we can start discussion. So the first link is the link where discussion can happen after this presentation for everybody who watched it or participated today. And there is initial Rust implementation done as a PR to LNPBP core library. Yeah, that's all.
I like it very much. I think that this is definitely an LNPBP project completely in diciamo, fitting the philosophy of LNPBP. I'm not sure it should be presented as a specific RGB stuff, meaning that inside there are RGB specific fields, but there are also Lighting fields, and it's not specifically a Lighting project. There are Miniscript related stuff. It's not a Miniscript project. So if we interact with Rusty and other people, I think that it could be better to frame it as a more general stuff than RGB specifically, which includes, of course, some RGB specific optional fields, because this I'm convinced that this could be extremely interesting for many applications, and not even applications that are not considering RGB at all. As another suggestion, I just say it here for pro memoria, but then maybe I will write it somewhere. I think that after a discussion I had with Rockstar Dev of BTC Pay Server, they did implement something vaguely similar in the, of course, it's not a standard for invoice, it's just a fallback situation, but they did implement some reasoning of that type during the checkout in order to start with a LN invoice and then degrade in a different way. So I guess they will be the first to be interested to try out to play a little bit with this new standard as soon as it is a little bit consolidated. So very nice. I like it.
Do you have any recommendations to learn more about My Citadel wallet?
Sorry?
Do you recommend any particular place or resource to learn more about My Citadel wallet?
No, not at this moment, because basically we need to finish it, and I had a plan for it to be ready by today, but basically I spent all the time I was planning to spend on it. I spent it on the RGB SDK and invoicing and the rest. So basically it's not there yet, but hopefully by the next week we will be demonstrating, and after that it will be open sourced. Literally right now there is not a lot of hope to open source other than UI, and the integration will use the RGB SDK that is already published and open source, and hopefully over this week I will be just integrating it and releasing. Long story short.
Thank you.
And answering Giacomo, yeah, I agree that it's not RGB specific at all. It can live without RGB even. Of course, the only RGB specific thing here is the one of the beneficiary types, which is blended UTXO. But the rest, nothing RGB specific. And that's why I propose to name it not like, again, we have the whole idea of LNPBP Standards Association was that it wouldn't be only about RGB. It would be about Lightning Network extensions. It will be about Storm and other proposals.